7th grade lesson 12.2 is experimental probability of simple events. An experimental probability is if you conducted an experiment like tossing paper cups 20 times to see if it lands on its bottom, on its open side, or on its side, you would record how many times it did each of those things, and then you would use that data from your experiment to get an idea for what's the chances if you flipped it 100 times rather than just 20. So experimental probability is the number of times, or the event is found by comparing the number of times an event occurs to the total number of times that you tried it. And you can do that in a fraction form. So the number of times the event happens in your experiment over or divided by the number of trials that you did. So if I were flipping the paper cup 20 times and it happened to land on the bottom of the cup, the bottom part down, twice, then 2 out of 20 times, or the reduced version of it, 1 out of 10 times, would be the experimental probability. If it landed on its side 15 times out of the 20 times that I flipped it, then the experimental probability of that happening, 15 out of 20. 15 times it landed on its side out of the 20 I tried. Reduced, you could reduce these, that would be 3/4. 3/4 of the time it landed on its side. And then, so the rest of it would be how many times it landed open side down. So experimental probability is just what you get out of your experiment. What were the chances of that happening based on your experiment? A simple event is where only one outcome for the event could happen. The outcome being, in this case, if I flipped a coin, or in this case, let's go back to this one. I turned it over. It's not going to go lay on its side and then do something else on top of that. It's going to lay on its side and done. If I flip it again, then it will land on, let's say it lands on its bottom. It's not going to land on its bottom and then go do something else after it's landed on its bottom. So just the one outcome for each time, that's the simple event. All right, and in this example, we have Martin, who has a bag of marbles with different colors in them. He removed one marble at random. He recorded the color. He placed the marble back in the bag, and he repeated this process several times, every time recording his results in the table. Find the experimental probability of drawing each color. So after he conducted his experiment, these were his results. He pulled out red 12 times, blue 10 times, green 15 times, and yellow 13 times. If we wanted to find the number of trials, remember, because it's the number of the outcome over the trials that you had. So we do need to know the total number of trials he had. So we would add those up, and they did that for us. So he tried 50 times. He pulled the marble out, recorded it, put it back, did it again and again and again, 50 times. Of those 50 times, it came out red 12 times. That simple outcome right there. So 12 out of 50 times, it was red. So the experimental probability, the reduced version of this, is 6 out of 25. Of the blue marbles of the experiment, blue marble came out 10 times in his experiment. That is 10 out of 50 tries. Reduce that. 1/5 of the time, it was blue. Green came out 15 out of the 50 times, reduce the fraction to 3/10. Yellow came out 13 out of the 50 times, not reducible, so leave it at that. And that's what experimental probability is. Also included in this lesson is talks about creating a simulation, which is a model of an experiment where maybe the experiment itself would be too difficult or impossible to do, so for whatever reason. So you can come up with a simulation. This is the example they gave of the simulation. So let's say a baseball team has a batting average of 250 or 250 thousandths so far this season. This means that the team's players get hits in 25% of their chances at bat. Use a simulation to predict the number of hits the team's players will have in their next 34 chances at bat. So this number again is 250 out of 1,000, 250 thousandths. So let's say out of 1,000 at-bats, they hit the ball 250 times, right? So we write that as a fraction. 250 ends in the thousandths place, so 250 thousandths, and reduce it to 1/4. So they hit the ball 1/4 of the time that they go to bat. And let's say we wanted to know for the next 34 chances at bat how they do as an experiment. Well, maybe I don't have a team to bring out to a field and do the experiment. So I need to come up with a simulation to act that out. So this person thought, well, a standard deck of cards has 4 suits: hearts, diamonds, spades, and clubs. Since 1/4 of the cards are hearts, you can let hearts represent a hit. Diamonds, clubs, and spades would then represent no hit. And that's your simulation. It's something in place of that has the same probability that you can simulate with. And you can pull 34 times, because that's what they asked for. Pull from the deck of cards. This is better than gathering up several players and going out to the baseball field and seeing how many times the whole team hits out of 34 at-bats. So they simulated it. They drew a card at random from the deck, recorded the result, put the card back into the deck, and continued until they had drawn and replaced 34 cards in all. Each were hearts. And so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 out of the 34 times were hearts in their simulation. You can make a prediction, count the number of hearts in the simulation. There were 11. You can predict that the team will have 11 hits in its next 34 chances at bat. So that's all they mean by a simulation. It's just finding another way to go through an experiment that will give you the chance to run the experiment even though you don't have the tools necessary to do the actual experiment. And that's all this is. This lesson is about is just that experimental probability. How many of the event happened over how many times you tried it in your experiment. What's that fraction in terms of probability?